Kumusta? I pray that we are all safe. For today's video, we will talk about network models. We have two network models. We have OSI model and TCP/IP model.
Every single day, I'm gonna make something great. That's my way. Every single day, I'm gonna make something great.
For data communication to take place and two or more users can transmit data from one to another, a systematic approach is required. This approach enables users to communicate and transmit data through efficient and ordered path. It is implemented using models and computer networks and are known as computer network models. Computer network models are responsible for establishing a connection among the sender and receiver and transmitting the data in a smooth manner respectively. So there are two computer network models, OSI model and TCP/IP model, on which the whole data communication process relies. First, we have the OSI model. The OSI model is one of the general-purpose networking or communication model among computer network models, which is responsible for establishing connection in an open manner between all the communicable devices present across the globe. OSI stands for Open System Interconnection, and the name of this reference model was given by an organization known as International Organization for Standardization. The ISO is responsible for generating and promoting industrial and commercial standards applicable for all the users or universally. OSI model is called as open source because of its fit anywhere ability. There are 7 layers under OSI model: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. At layer 1, the physical layer of the OSI model is responsible for the ultimate transmission of digital data bits from the physical layer of the sending or source device over network communications media to the physical layer of the receiving or destination device. Examples of layer 1 technologies include Ethernet cables and hubs. Also, hubs and other repeaters are standard network devices that function at the physical layer, as are cable connectors. At the physical layer, data is transmitted using the type of signaling supported by the physical medium: electric voltages, radio frequencies, or pulses of infrared or ordinary light. When obtaining data from the physical layer, the data link layer checks for physical transmission errors and packages bits into data frame. So sa kaning layer, mo ni siya nga layer ang responsible for reading and writing data from and onto the line. So ang mga link errors pod kay ma-detect ani nga layer. Because the data link layer is the most complex layer in the OSI model, it is often divided into two parts: the media access control sublayer and the logical link control sublayer. The network layer adds the concept of routing above the data link layer. When data arrives at the network layer, the source and destination addresses contained inside each frame are examined to determine if the data has reached its final destination. If the data has reached the final destination, Layer 3 formats the data into packets delivered to the transport layer. Otherwise, the network layer updates the destination address and pushes the frame down to the lower layers. To support routing, the network layer maintains logical addresses such as IP addresses for devices on the network. The network layer also manages the mapping between these logical addresses and physical addresses. The transport layer delivers data across network connections. TCP or Transmission Control Protocol and UDP or User Datagram Protocol are the most common examples of transport layer. Kani pod nga layer kay responsible for end-to-end delivery between hosts. The session layer manages the sequence and flow of events that initiate and tear down network connections. Of this layer, it is built to support multiple types of connections that can be created dynamically and run over individual networks. Sa kanipod nga layer, mo na siya nga layer mag-maintain sa sessions between remote hosts. For example, once user or password authentication is done, the remote host maintains this session for a while and does not ask for authentication again in this time span. The presentation layer has the simplest function of any piece of the OSI model. At layer 6, it handles syntax processing of message data such as format conversions and encryption or decryption needed to support the application layer above it. So kani nga layer, mo na siya mag-define how data in the native format of remote host should be presented in the native format of host. The application layer supplies network services to end-user applications. Network services are protocols that work with the user's data. For example, in a web browser application, the application layer protocol, HTTP, packages the data needed to send and receive web page content. This layer provides data to and obtains data from the presentation layer. Next computer network model is TCP/IP model. TCP and IP are separate protocols that work together to ensure data is delivered to its intended destination within a network. TCP stands for Transmission Control Protocol, while IP stands for Internet Protocol. The four layers in TCP/IP model are link layer, internet layer, transport layer, and application layer. The link layer is the lowest layer in the Internet Protocol suite, the networking architecture of the Internet. The link layer is a group of methods and communications protocols confined to the link that a host is physically connected to. Or ang kaning link layer, mo na siya nag-provides mechanism of sending and receiving actual data. The Internet layer is responsible for sending packets from a network and controlling their movement across a network to ensure they reach their destination. It provides the functions and procedures for transferring data sequences between applications and devices across networks. The transport layer is responsible for providing a solid and reliable data connection between the original application or device and its intended destination. This is the level where data is divided into packets and numbered to create a sequence. The transport layer then determines how much data must be sent, where it should be sent to, and at what rate. It ensures that data packets are sent without errors and in sequence and obtains the acknowledgement that the destination device has received the data packets. The application layer refers to programs that need TCP/IP to help them communicate with each other. This is the level that users typically interact with, such as email systems and messaging platforms. It combines the session, presentation, and application layers of the OSI model. So that was the two computer network models, the OSI model and the TCP/IP model with their respective layers. Computer network models are important because it is responsible for establishing a connection among the sender and receiver and transmitting the data in a smooth manner respectively.